All right. Hello and good morning or good evening, good afternoon, whatever it is, wherever you're at. My name is Brian Kostanich and I am co-founder and CEO of Wilderness Labs. And I am joined today with Adrian Stevens, who is an advisor and hangs out and plays with us in hardware. And today we're going to be talking about building production IoT using our platform called Meadow. Now, before I get into that, though, I want to talk a little bit about the industry because a technical revolution is in progress right now. In my lifetime, we've gone from this idea of putting a computer on every desk in every home. This was a famous Bill quote from like the late 80s or early 90s, a vision of his, to a time in which we can put computing in just about everything everywhere. And this is really changing our the way that we interact with technology, and it's a big it's a big changeover in humankind's technological progress. In the last 10 years, basically all we talked about was mobile, and was mobile, and this next 10 years is about hardware. And to give you a sense of just how big this changeover is, today hardware is already 3 times the size of the mobile market. And in just a few years, there will be 10 times as many non-mobile connected devices on the planet as human beings. And this has really driven IoT development into the mainstream. But what's interesting about this is, unlike mobile, which gave you a hero experience in the palm of your hands, the IoT that we interact with, consumer IoT, is just just the tip of the iceberg of the overall market. So we don't really have a sense of how big this revolution is the way that we did with mobile. And in fact, the vast majority of the market is happening in industrial and commercial solutions, so transportation and ag tech and manufacturing, etc. This is where the bulk of hardware is, smart hardware and IoT is actually being developed. And in these places, IoT solutions are changing how things are manufactured and how logistics are done in a real massive way. And in fact, nearly every enterprise today is building IoT. And this is important for us as developers because our hardware skill sets, or the embedded developers, are really in demand right now. And while there's a high demand for tech workers all across the industry, that will ease up at some point. But the demand for hardware developers will continue on for years. This is probably the next 10, 15 years. This is going to be a huge demand and not enough developers to fulfill that. And while all this is happening, there's really a challenge in this space in the hardware industry, because today it's really hard to build hardware and almost all projects are failing. Now, they're failing early, which is good, but they're still failing, which is bad. And a big part of that reason is that today IoT is built almost exclusively in embedded C, and an embedded C is a low-level platform. It's hasn't changed a lot since the 70s, and unlike modern platforms, you have to do everything yourself, and it takes much longer to do anything in it than other modern platforms like .NET or JavaScript, TypeScript, etc. And you spend a lot of your time on low-level plumbing, and then you're fighting with drivers, trying to get them compatible with your operating system, and there's a little mismatch in quality of the code out there, etc. And it's a real challenge. So we set out to change that. We wanted to turn that on its head. So our mission at Wilderness Labs is to make building hardware as easy as web or mobile development. And to that end, we've created a platform called Meadow. And Meadow is just a better way to build IoT. And at the heart of it, we enable you to use your existing .NET skills and use them and build on real hardware, on microcontrollers. And today we support .NET Standard 2.1, and we're working on the switch over to .NET 6, which will come soon. And we enable you to manage those devices out in the field at scale. So this is really a production platform. And security is a big part of our platform, and we'll talk about both of field management and security in a moment. But this is really something that we designed for, like I said, production or enterprise IoT. That's real world where you need to manage it, you need security, and at the heart of this, we've started with fantastic hardware. So we've got low energy microcontroller based modules with a bunch of connectivity, and we've got both developer modules and high volume modules or SOMs. And the idea here is that you go from prototype to development on the same hardware. There's no, like what happens today for a lot of IoT is that folks generally prototype on an up-level platform like Raspberry Pi or something, and then when they're ready to go to production, then they have to rebuild and rewrite on embedded devices. And that, we eliminate that with Meadow. You start on hardware from the beginning and you deploy on hardware. And at the base of the software stack for us is Meadow OS, which is built around a micro RTOS, micro real-time operating system kernel. There's NetX, and it provides OS services. We have SQLite built in. There's configuration, power and sleep APIs, etc. And then on top of that, there's a bunch of really beautiful hardware APIs for interacting directly with the hardware. But we've also created this thing called Meadow Foundation, which is this massive open source peripheral driver library. And the idea with this is that we built these drivers so that you don't have to use the hardware APIs. This makes hardware plug and play. So you grab peripherals off of SparkFun or Adafruit or whatever, you plug them in, and there's just an API, and you're ready to go. And so that's the actual code. This is really building hardware like software. And there's no real tool chain setup. You simply install an extension for Visual Studio or VS Code. We support Mac, Windows, and Linux. Full debugging. Everything that you would expect in a modern experience. And it's actually very fast to deploy. In fact, we're much faster to deploy than, like, say, Arduino. And as I mentioned, security is a big part of our stack, and so you can put your device when you're ready to start testing in production. You put it in production mode, and you get identity services around key management, and then a big part of this is also our secure boot. So the device will only run signed encrypted application and OS packages. So this is very similar. It's basically the same feature that Microsoft touts with Azure RTOS, right? The idea that you can't sideload an app because this is, the app really has to be signed for that device, similar to iOS App Store, etc. And there's also, the whole device, all the storage gets encrypted, and then over-the-air updates are available, and then there's a whole bunch of trusted platform computing features like hardware crypto, and of course things like TLS or SSL are built in. And for those of you folks who have done hardware development before, that's actually kind of a nice feature, because adding HTTPS to these devices is often a real bear of a time. And with Meadow, it's a built-in first-class feature. You don't even have to think about it. And the other thing that we've done, and this is something we just launched recently, is our first IoT Reference Kit. And this is an accelerator for those who want to learn how to build IoT, because it's one thing to blink an LED, it's another thing to create an end-to-end IoT product. And Klima is, of course, Spanish for climate, and this is a solar and battery-powered climate monitoring station, and monitors air quality and weather and whatnot. And it does all the things you expect of an IoT device. It uploads data to the cloud and synchronizes, and then it's got a Bluetooth interface, so you can, along with a Xamarin companion app, so you can connect to that device and see the real-time data from the sensors. And there's also a RESTful web API, so if you want to integrate that way and do things, talk to it that way, then that's available. And it's all open source. Everything, the designs, the hardware designs, the enclosure is 3D printable, and both the source and the STLs for printing is in the repo. And we just launched this, and we'll be shipping these next month, so you can pre-order yours today. And I would say, if you want one, this is actually, we're doing a very limited run of these to begin with, so they will sell out. So if you want to get in line for these, definitely pop over to our store, store.wildernesslabs.co, and grab one. So this is really IoT for every developer, and there's a bunch of folks building production IoT with Meadow today. There's a county just across, just over next Portland is building sensors for water treatment management to optimize their efficiency. We've got a customer in the UK who's building a bolt-on energy meter to provide, again, to reduce energy, optimize efficiency, and prevent downtime, and when it needs a device, it might need preventative maintenance. We've got a customer building a CO2 sensor that would indicate the transmittability of CO2, and this can be used to optimize your HVAC system and make sure that public spaces that you're going to are safe. And this is a project that this is actually my own project. I've been building a smart beehive in partnership with Portland Urban Beekeepers and Oregon State University. And the idea here is that we're trying to reduce or eliminate colony collapse disorder because we're losing our bees. And honeybees are a key component of our food supply chain. So this is super important. A lot of places where this is another place where IoT is really making a difference. But what I want to show, I want to hand this over to Adrian, who's going to show us Klima. I'm going to walk through and see this in action and see how this actually all fits together and how it really is just .NET code running on real hardware. So, Adrian, thank you for joining us. Take it away.
Fantastic. Thanks, Brian. So let's take a closer look at Klima. So I've got some hardware behind me. We've got our weather station. We've got wind direction and wind speed on the hardware. And of course, the brains of it is our Meadow board. It's our Meadow F7. It's mounted to a custom PCB, which does a couple of important things. One, it has some connections for our hardware, so we can read our wind speed and direction. And it also contains an atmospheric sensor that we use for additional data. And I'll talk about that in just a moment. But let's really get into how we control and program our Meadow board. Now here I've got Visual Studio Pro open on Windows, and I've got a .NET solution open. A number of projects in here. Part of this is for a Xamarin Client application to read data. We'll talk a little bit about that, but won't go into detail. All of this code is open source. You can dive in more on your own. But for now, I'm going to focus on this Klima Meadow Pro project, and that's the code specifically for this hardware. Well, it's here. I'm just going to focus on the right-hand side. Notice there's a couple of NuGet packages here. Yeah, NuGet. We can bring in those standard .NET NuGet packages like SQLite.NET and System.Text.json to our .NET projects. So a quick tour, and I'm going to start with program.cs to show you a couple of things. So notice public static void main, our old friend here. If you're a .NET developer, you've probably seen this in other application types. This is one important thing, and it instantiates our Meadow app class. And that's important because Meadow app derives from this app class that understands the F7 v2 hardware. And that's important because it knows the hardware configuration on this device. So it knows how to talk to the general purpose I/O, the communication buses that allow us to connect and talk to the physical things attached to the F7. And it does this through a device property, which we'll see in just a moment. So let's start by looking at a couple of drivers. And I'm going to jump into our climate monitor agent class and scroll up here to the top. And so this does a lot of things to read data, and it has some event handlers and good things like that. But I want to focus on these peripherals, and these are classes. They're objects that represent our physical sensors. We've got our BME280, that's our atmospheric sensor that's on our custom PCB, and then the wind vane and our wind speed. And I want to focus on this BME280. This is an interesting one. It's actually a complex little chip, and you might normally have to go through and understand all the communication protocol specifics and the bits and bytes. But here we don't have to because of Meadow Foundation, as Brian mentioned. So the BME280 talks over I2C, it's a communication protocol, and that can be complex, but here, actually, it's pretty straightforward. I mentioned that device class from our app class. Well, that's what lets us talk to the physical thing. And there's a method here, create I2C bus, and that creates the I2C bus instance, so we can talk to I2C things connected to the I2C pins on the physical hardware here. Just that easy. And then for I2C, we need a specific address. So there's always a specific address for each piece of hardware. That way we can have more than one thing on the bus. So we need to know what the BME280 address is, and look at that. It's actually a static property right there on the BME280 class. So no guesswork. One line, instantiate, doing a lot of work here. And what's great now is we've now done all the wiring for the physical part, and now it's just .NET, and this is what I love. So let me show you how this all works. And really, in a way, you already know how this all works. In the example here, we have a read method. Good old .NET, it's async, returns a task, returns a climate model object. And here we want to interact with our BME280, so we're just going to call methods on our BME280. In this case, it's a read method. And this is actually an async method. This is a fun little trick here. So we're going to call read on our BME280, read on our WinVein, cache those tasks, and then call when all. And so when we've got the data back from both of our sensors, we instantiate our climate model object and return it from the read method so we can go do things with it. Again, we're just into .NET now. There's really no surprises. So what might we do with our data? Well, let's probably store it somewhere. What should we store it with? Well, let's go to our database and take a look. So we've got our local database manager, and I love this, using SQLite. So we're going to store our data in SQLite using our favorite ORM. Remember, we saw a NuGet package, SQLite.net. A lot of this should be familiar, especially those of you from the mobile world. We create our SQLite connection. We scroll down, we give it a database path. Meadow has some definitions for local for the file system. So we've got a data directory, for example, which is a great place to put our database, instantiate it, configure the database. How do we do that? Well, we give it a well-structured model object, create the table, and we're ready to go, and we can start storing data into our database. Again, this is common stuff, SQLite.net. Now, we might want to get some data off the device. Remember I mentioned our Xamarin Client application? Well, this is all wired up to use Bluetooth. So I'm going to show you our Bluetooth server class. So Bluetooth can be a little bit complex, but I'll show you it doesn't have to be, and I'll show you how this is all working here. So the big thing to take away here is we define what we call characteristics. And you can kind of think of these as our endpoints. We're going to put data on our characteristics, so things that are connected via BLE can read those values out. Temperature, pressure, humidity from our BME280 and our wind direction. So got a Bluetooth server class. Let's scroll down. And I won't go into all the details, but you can see down at the bottom, we can create our characteristics. Bluetooth characteristics need a unique identifier. And again, it's all well documented, just some patterns for BLE. If it's complex, this is a great way to learn. Really great example. And then what's fun here is when we update, well, we just pass the data in, and then we update our characteristic, and that's going to update the values on our endpoints. And so our mobile devices, or really anything that speaks, that communicate over BLE, can now read our atmospheric data from our hardware. So we might want to get data off this device other ways. We could expose an HTTP server on this. There's a package, a NuGet package, published by Wilderness Labs called Maple. So you could have a little micro web server on here and connect it from your phone on your local Wi-Fi network. Or you could send it up to the cloud. So I'll show you a really quick example here, and kept this light just for ease of consumption. And I'm going to open up our climate service. Now, this is wired up just to connect today to something local on the network, but of course you could modify this to upload to your favorite cloud, of course, something like Azure. And I want to show you a couple of things. So here we're instantiating HTTP client object. Again, it's .NET, no surprises. We need to serialize and deserialize. Let's use system text JSON. We pull the NuGet package in. And again, familiar patterns for .NET applications. So all this is on open source. We'll share the a link to the GitHub repo. And again, this is a nice example of not only how to communicate with hardware, how to build out with HTTP and Bluetooth, reading data with physical things, but it's also a nice architected system here too. So you can see I've got classes for each piece of the code. Again, so go check it out. And I believe, yeah, Wilderness Labs is selling a full kit with all of this here as well, so you can go build your own climate station. Back to you, Brian.
Awesome. Thank you, Adrian. That was a fantastic demo. And I hope everyone saw just how easy it really is to build hardware with Meadow. And I'm sure you're all excited to get started. So, my recommendation is go get inspired, head over to our Hackster page, see some of the cool things people are building and get some ideas. Go over to our the Wilderness Labs store at store.wildernesslabs.co, pick up a kit, and we'll be shipping those out very soon. And then head over to our developer docs at developer.wildernesslabs.co and get started. And also, I want to tell you about something very awesome. Next week we are having our second annual developer conference, Wilderness Labs Dev Camp, and this is a full day of Meadow goodness, a lot of deep dives. We're going to get down into the technical bits of it all, and it's going to be a fun day. And there's a bunch of really, I think, very exciting announcements that we're going to talk about in the keynote. That if you are interested in Meadow and you're interested in hardware at all, it's going to be very good, very cool. I'm really excited to tell you about a bunch of stuff that we're launching and a bunch of new stuff that's coming out. And if you do register, it's a free event. But if you register and you put in the lottery for might win a hack kit. So very cool. Looks like first of all, thanks for joining. Looks like we have a few minutes for questions. So I think we're gonna open up the floor for you to got questions, want to talk about IoT? Let's do it.
All right. Let's go into a mode where we can see each other. Brian, if you're ready, I'm going to bring you in. There you are.
Hello.
And Adrian, if you're ready. There you are. All right. So that was amazing, folks. And you're so on point because, hardware it's tricky at times, but you're trying to make it easy.
Yeah, that's right.
Yeah. Yeah, and I took note of the URLs with Wilderness Labs, and thank you for what you're doing. If I can, just share one thing with excitement. This is Matthias Castillo, if I'm saying your name right.
Hey, Matthias.
Hey, IoT time indeed.
He's a friend of Wilderness Labs.
Oh, there we go. I don't want to give a lot away, but this is IoT time, as you will see in our next session. So very exciting time. I did want to ask you like two questions, and they may be dumb here, but I'm going to ask away. So you mentioned in the demo that the Bluetooth LE communication can sometimes be a little tricky. Could you tell us a little bit more about it?
I'll jump in, but Brian can add on to it. It's a straightforward API, but it is a complex API, and it's my read on it is it feels similar in a lot of ways to have a web service, but the names, the conventions are different. So it's like everything else in tech. It's almost like learning a new language. Once you know the patterns, it actually makes a lot of sense. Brian, if you want to add into that.
No, I think that's 100%. I mean, it's a wonky protocol. It is what it is. It's BLE, but we make it super easy. That's I think the upshot there is that we take the kind of wonky protocol and we make it simple. And by the way, we have a companion app in our repo that's Xamarin app that actually connects to the device, and then you can see the real-time stuff from Xamarin app. Connecting over Bluetooth using I think the Xamarin Essentials Bluetooth or something.
Yeah, I saw that, and then the whole Klima thing sounds so enticing. I mean, it's just ready out of the box, and I can test my air quality just from a phone on a device. That's amazing. So since we are talking IoT, I think we have like 1 or 2 minutes left here. I do want to ask you maybe something uncomfortable, but with IoT, sometimes you see a lot of applications. Some of them are super enticing, super interesting. Some maybe a little cringeworthy. So in your experience of being in the IoT space, tell us something that you've seen is super unique and very useful, and maybe something that's maybe.
You know what? I've seen a cow collar, which I thought was really interesting. It goes around a cow and it tells you all kinds of health information about the cows, which sounds kind of funny, but if you're a dairy farmer, the insights that you get on the health of your animals can actually tell you a whole lot about their milk production and things like that. And so that was, like ag tech is huge, right? And then IoT is absolutely transforming ag tech right now, as well as like all manufacturing and industry and whatnot. and so that was interesting. I saw another in ag tech where it's a little ball and it has a sensor inside, and you drop it on top of a grain silo, and then it tells you the the humidity and the temperature of the grain and stuff. Make sure that it doesn't spoil, and you can move it out if it's something's going wrong or whatnot. I think the sort of all-time Razzie Award for bad IoT was that juice squeezer, right? The one where you bought the juice in a packet and then squeezed. But honestly, there's a lot of really amazing IoT being built today. And like I said, almost everyone is building IoT or is tasked with IoT today. So it's, the things that we're going to see over the next few years. I like draw the analogy to Google Maps. I mean, mobile, like smartphones are not that old. It's like what, 14, 15 years ago that Steve Jobs stood on stage and showed us the iPhone. Imagine, like, can you remember what driving was like before Google Maps and then after Google Maps, right? IoT is going to have that same sort of effect. In another 10 years, there's going to be things in our life, in our professional life and certainly in industry and stuff, we're going to be like, how did we live without this particular thing? And it's really up to the imaginations of folks to see what they build. But it's our job to make it easy. So, that's why we're here.
Well said. And you are making it easy. You are bringing it close to developers. And like you said, like there are so many industries with so many applications. Like, agriculture is big. When you talk about like ethically doing things, IoT lets you have visibility into things that you just will not have. So thank you for what you do. Thank you for coming out and sharing what you have done so far. This is amazing.
Thanks for having us, Sam. Thanks for hosting.
Thank you so much.